Forestry on Parade. A pictorial review of events in business and industry, produced each week by the National Association of Manufacturers.
A vast open-pit iron mine on Minnesota's Mesabi Range, the original iron ore country. The fame of man-made canyons like this, one of the 5 mines of U.S. Steel's Oliver Iron Mining Company, has spread throughout the world, and spreading with it, the products of iron and steel made from the 50 million tons of ore that come out of these pits each year. But as the Mesabi's high-grade ores become exhausted, only research and the development of extensive processing facilities keep the vital mines producing. Now they can beneficiate the lower-grade ores, treating them to remove sand and other extraneous materials. And soon they'll even be processing extremely hard, iron-bearing taconite rock, extracting a fine powder of iron ore, then forming it into egg-sized lumps that can be used in the furnaces. By railroad, the ore is carried to Lake Superior in a volume great enough to make Duluth, Superior, the 2nd busiest port in the nation in terms of tonnage hauled. Here we see the operation of the Great Northern in one of the most efficient, large-scale materials handling jobs on Earth. Automatic scales buried under the tracks weigh every carload as the wheels pass over the tripping mechanism. The cars have all been carefully sorted according to grade, physical characteristics, even the amount of moisture the ore contains. For some distant steel mill requires a boatload of ore of exact quantity and analysis, and that's what it'll get. A power-driven wrench on the truck opens the trapdoor that dumps 75 tons of ore into one of the bins. Capacity of each bin, 300 tons. "300 tons into the hole. With clock-like precision, the spouts are lowered in turn. A 10,000-ton ship can be loaded in 4 hours and a half. By nightfall, the ore will be on its way to steel mills of Illinois, Indiana, Ohio, or Pennsylvania. When the holes are filled, no time is wasted getting the boat underway. The Great Northern ore docks alone average 18 loadings a day. The hatches are closed, and another cargo of ore is on its way to wind up ultimately in any of the thousands of forms in which steel serves the nation. But even with its new techniques for extracting ore from well-worked mines, the steel industry takes no chances on our being caught short of this vital mineral. Very actively, it safeguards and extends our sources of iron by developing mines like El Tofo in Chile, where Bethlehem Steel uncovers rich new ore deposits. 58% pure iron. And our quest turns up equally startling finds in Quebec and Labrador, Venezuela, Liberia, and Brazil, all now being tapped to benefit not only the people of those countries and ourselves, but the entire free world. In addition to its shipments to the States, Chile, under American guidance, has been able to develop a steel industry of its own. In the race for time with Stalin and company, steel is all important, and we have no intention of coming in second.
Through the years, Americans have learned that machines create jobs. We know that machines have shortened hours, raised wages, and made it possible to manufacture the things we need for our standard of living at prices that people can afford to pay. Machines make life easier for everyone. They do the work and remove the strain. They call for greater specialization. That gives workers a chance to use more mind and less muscle and to develop new skills. In short, it makes them masters of the machine. operators, inspectors, and supervisors.
Here's the answer of a Cleveland company to the continuing need for well-built, inexpensive housing. One of the numerous low-cost structures put up by Expand Homes Incorporated. Families by the hundred are enjoying the deep pleasures of settling down in their own homes. Homes that combine the latest engineering techniques with traditional construction methods in such a way as to counter the rising costs of inflation. At the Expand Home plant, Western pine and Douglas fir arrive in carload lots to be cut into the studs, braces, truss frames, and other parts that make up a house. Wall panels are covered with plywood or homosote sheathing, 3 to 5 times stronger than ordinary sheathing. But the most important innovation is the factory-built roof truss, which supports the roof just as trusses support a bridge. This means all the weight is carried by the outer walls, none by the interior partitions. Result, the roof can be put up in record time, and flooring laid an entire story at a time instead of room by room. Patented ring connectors give the trusses tremendous added strength. All the work that can be done best and least expensively in the factory is done there, with the assembly line methods that have made other products so plentiful here in America. This also speeds the work at the home site. Once the poured concrete foundation has had a chance to set and floor joists and subflooring have been installed, the stage will be set for the home that comes in a package, its component parts all pre-assembled. 10 hours to pour the foundation, half a day to put down the subflooring. Now let's see how long it takes our crew of 5 to finish the rest of the house, here arriving all on one specially built truck. Along with trusses and wall panels come doors and door sashes, metal casement windows already set in wood, stairs, shutters, the works. With walls pre-built, there's no need for scaffolding, and our 5-man crew can erect the walls in 20 minutes. Up it goes, door and all. The window assembly will go into the opening quickly, easily. There are 9 basic floor plans for Expand Homes, and on each of these there can be 6 or 8 additional variations. Once the walls are up, the roof trusses and gables are set in place, ready for the roof. Total time elapsed since the truck arrived, about an hour and a half. Roof sheathing takes a little longer, just under 4 hours, with another couple of hours for the shingles, less than an hour to install windows. With some of the team finishing up the outside while the rest put the final touches on the interior of the house, in no time at all, comparatively speaking, a home is ready for another of our millions of growing families. The Cleveland Plan, demonstration of how even housing shortages fail to stand up against our industrial ingenuity.
Meet a group of Kansas City executives busy figuring out new ways of dispensing by machine every conceivable product from peanuts to toothbrushes, nylons to ice cubes. They're the men who run the Vending Company, a firm that pioneered in the manufacture of vending devices with a coin-controlled machine for the merchandising of cold bottled soft drinks. Now, as with the dispenser of ice cream bars we see in preparation here, the industry has branched out in all directions and is still finding new fields to conquer. Construction must be really rugged, for the machines located in public places will often operate under difficult conditions 24 hours a day. The bright enamel finish will be baked on so it too can withstand a lot of wear and tear. The parts are brought together. Sub-assemblies include the coin-operated unit for producing one article at a time, as well as the refrigeration unit for those machines that must have one. Quite an order for a device that's expected to be very compact and at the same time hold as much merchandise as possible. Another demand made on the vendos, that they require a minimum of maintenance. Painstaking tests of the assembled machines help ensure that they'll produce the ice cream bar or other product every time a coin is dropped in the slot. Meanwhile, right in the same plant where vending machines are turned out, other vendo workers are busy filling important defense orders for high-reaching antenna towers for the Signal Corps, minute radar and other electronic machines, as well as other projects known only to the Vendo Company and Uncle Sam. Our cameraman is not allowed in the area to which entry is possible only by producing the proper identification. A truly remarkable achievement, the way this and other American industries have been able to keep up with a flood of war orders while satisfying the greatest demand for civilian goods in the history of the world. Thus, in offices, stores, terminals, wherever people need a snack or a service, there's a vending machine there to serve them.
Thanks to reforestation and conservation, there is enough saw timber standing today in the nation's forests to build a 6-room house for every man, woman, and child in this country with lumber left over. This is true despite the fact that twice as much wood has been removed from America's forests as was grown when the first English settlers arrived. Today, each new wood growth of all sizes equals 98% of the amount removed and destroyed by fire, insects, and disease. Forests of the United States can continue to fill all requirements.
Let's face it, we Americans don't keep our highways as clean as our living rooms. But a big step toward counteracting the work of the litter bugs has been taken by the California Division of Highways with a super vacuum cleaner that'll pick up everything short of the concrete itself. A modified product of the Good Roads Machinery Company of Minerva, Ohio, the litter collector works on the same principle as a home-type model. A big fan inside creates a vacuum that sucks up cans, boxes, paper, even gallon jugs. Working by hand, one man stationed every couple of miles can't keep a busy highway clean. But a crew equipped with the highway vacuum cleaner collects as many as 50 cubic yards of trash a day. Debris that was found scattered along one short stretch of road. It shouldn't have been thrown there in the first place, but since it was, it's a good thing we have a machine to restore the beauty of the open road.
Industry on parade. A pictorial review of events in business and industry, produced each week by the National Association of Manufacturers.
Try to count the wheels on this fast-moving streamliner. Even if it were standing still, you'd have to spend quite a while counting all of them. There's an awful lot of weight on those wheels, weight that must be carried by bearings. And if the bearings aren't constantly lubricated, they'll burn out. Making sure the oil doesn't leak out so the bearings will continue to roll is the purpose of the National Motor Bearing Company of Redwood City, California. The company's president, Lloyd A. Johnson, examines blueprints for an oil seal that may eliminate the hot box, a railroad man's greatest dread, the thing that's caused many a derailment. In the lab, Experimental molds are made and tested. An oil seal for a railroad car is an unimpressive-looking instrument, but it has a very impressive job, keeping the lubricant around bearings and keeping dirt and water out. That means an extremely tight fit, yet one that holds up under friction. The key lies in the material used for the sealing flange. Leather formerly was used exclusively. National motor bearing engineers now bond rubber to metal to provide a permanent built-in gasket. The press opens, and flattened inside the mold is a metal and rubber object shaped somewhat like the old straw sailor hats. Just one of many hundreds of parts that go into a railroad car, but one that may mean the difference between 1 year of trouble-free service and 3 or even more. The new development gets extensive workouts in the laboratory and under actual working conditions. It's tested for its reaction to long periods of high temperatures as well as extreme cold. When approved, the plant tools up to produce it. Meanwhile, the firm produces a great many oil seals for other uses and uses a good deal of quality leather that's gone over by experts who make sure it's just the right thickness and who mark off any imperfections. The leather is then cut by other experts who hold waste to a minimum. The leather discs must be molded to the proper shape, a job accomplished by means of heat and pressure. Wherever shafts turn, oil seals are required. Automobiles use from 7 to 14 of them. Even lawnmowers often use a pair. They're another of those products of which the public is unaware because they're something the public rarely buys. Yet the painstaking research that's gone into the development of better oil seals and the methods they've been devising for producing them better and less expensively pay off for all of us in the end. For if tons of lubricating oils are wasted on equipment that we use, and costly repairs or even costlier breakdowns result, you know who pays the bill. Here's one more industry that stands behind other industries to help supply our ever more diverse needs.
Inflation, which has chipped away nearly half of our 100-cent dollar in the last dozen years, continues to plague the nation's consumers. Homemakers feel the effects whenever they shop for their families. Businessmen feel it in rising costs, and the government sees it in the cost of defense material. The way to halt inflation from continuing to decrease the value of our present 53-cent dollar is to get the government to keep the federal budget balanced by cutting spending, by adopting a sound tax program, and by elimination of every cent of waste.
Low-priced homes, one of the most imperative demands of a rapidly expanding America. It's a demand to which an old Milwaukee manufacturing company, the Harnisch-Fager Corporation, turned its attention some years ago, applying the same techniques that have made America the leader in the production of every imaginable type of goods, from crayons to traveling cranes. Here's how houses are made by those same mass production methods. If women can pound nails, let them pound. The parts of a house are sub-assembled, as in Harnisch-Fager's diesel engine or welding machine plants. By concentrating on one operation, each worker becomes a past master at his particular assignment. On one of the few moving production lines in the home building business, studs and joints for the side of a house are coated with a powerful glue to hold exterior panels fast. The panels are set in place as the line moves along at the rate of 2 miles an hour. Power nails provide pressure while the glue dries, bonding the wood permanently together. On the inside of the frame will go fiberglass insulation. Adhesive is applied to hold it in place, then the insulation is fitted between the studs. The interior panel, pre-cut and coated with a vapor barrier, is now applied to the inside of the frame and glued and power nailed in the same way as the exterior panel of plywood. Elsewhere in the Port Washington, Wisconsin plant, gables and other sections of the prefab houses are put together, using skills and machines that are as up-to-date as the designs. After glazers and painters have done their work, the various parts of the house move toward the loading dock, where everything necessary for the construction of one house will be loaded into one trailer truck. An important advantage of this method of home building is the speed with which the house can be put together when the parts arrive. That and the tremendous savings possible through mass production help account for the widespread interest currently being given to prefabricated housing, whereby the home buyer of moderate means can obtain the careful construction, quality materials, and painstaking workmanship usually found only in more expensive homes. What's more, the buyer gets to live in his new residence without waiting 6 to 18 months. Industry on Parade calls on a St. Louis firm that's one of the biggest refrigerator manufacturers in the world. Do you have a Hussmann in your home? Not likely, for all the refrigeration equipment produced here is for stores and other commercial establishments. Huge power presses, shears, punches, and drawing machines stamp, cut, and shape metal parts for the refrigerators that have revolutionized America's food merchandising methods in a single generation. This tremendous press shapes the large end panels. Traveling on moving chains, the metal parts get a high-bake enamel finish. Compressors, vital to any refrigeration system, are mounted on their bases, after which flywheels and coils are added. This is the part that puts pressure on the gas inside the system, and when that gas expands, it absorbs heat, chilling the inside of the refrigerator. So the compressor is really the heart of the equipment. These compressors will be submerged in water and given other exhaustive tests and trial runs before being installed in refrigerators. Hussmann credits its success in its field largely to the skill of its workers operating with the superior equipment obtained with capital supplied by investors. Insulation, of course, is vital to modern refrigeration. Though much less bulky, insulating materials used today are far more effective than those used, say, 20 years ago. The refrigerator being assembled is a 2-deck self-service dairy case, from which customers can help themselves to eggs, butter, cheese, and so on. Hussmann helped pioneer this self-service angle, just as it did in producing the first refrigerators that doubled as display cases, and in introducing humidity control to keep chilled foods fresh and tasty. All major steps in transforming our food markets from the dark, unsanitary places they were not so many years ago into the bright, glistening, well-stocked supermarkets of today, in which foods from all parts of the land are laid out in far greater array than you'd find at the banquet of a Middle Eastern potentate.
In today's troubled world, American freedom stands as a beacon of faith, hope, and courage to the millions of people on this earth who have been forced to forfeit their individual rights for a life of human slavery. No American in his right mind would trade our way of life for one endured in Russia or any other country behind the Iron Curtain. Since our inception as a free nation, millions of citizens have laid down their lives in order that America could remain free. 156 million Americans have learned that the price of liberty is eternal vigilance.
On the streets of the nation's capital, we're watching a rodeo without horses or cowboys. It's a roundup of teenage automobile drivers patterned after the National Truck Rodeo, in which the country's top professional truck drivers compete each year. Sponsored by the Junior Chamber of Commerce and the Liberty Mutual Insurance Company, the idea behind the competitions is to help instill safe driving attitudes in young minds. At the National Guard Armory, young people from all over the country, after their road test, take a written quiz that would stop many an older driver right in his tracks. They also have a workout on an automatic psycho-physical testing device that rates a driver's reaction to just about any situation that might arise on the highway. Then, back at the wheel, they are asked to maneuver cars through the most intricate mazes with only inches of clearance and without putting heads out windows. Some don't make it. The judges note every aspect of the contestants' driving technique and carefully record their ability to stop on a mark, not with the screeching of tires, but smoothly and quietly, which means safely. Another test, parking the car without banging up your own or somebody else's fender. One try, and then the judges determine how far you are from the curb. In the straight line test, the car must be driven between tennis balls set out with a margin for error of only 1.5 inches. It's the hope of the JCs and Liberty Mutual that by giving our young drivers a chance to prove their skill, they'll call attention of other youthful motorists to the urgent need for safety.
Industry on parade. A pictorial review of events in business and industry, produced each week by the National Association of Manufacturers.
Moving into the Milwaukee plant of Grady Foundries Incorporated, another magnet load of scrap. Just about the only material used here in the production of steel for castings. Ordinary steel is made of varying percentages of raw iron mixed with scrap. But stainless, nitralloy, and other high-quality steels are made entirely of scrap. Alloyed, of course, with small amounts of certain other elements. One of those elements is carbon. And the amount of carbon in the melt has important effects on the character of the steel being produced. Here's how skilled steelmen determine whether the carbon content is right. They make a test bar in a little mold and harden it with a quick chilling. Out of the mold, the test bar gets another dip, then is placed in a special jig to be broken in two, so the newly exposed surfaces can be read. As revealing to a veteran melter as the pages of a book. But checks like that are only approximate when compared to the painstaking chemical analyses constantly being made at Grady. Analyses that allow the makeup of the metal to be rigidly controlled. Steel is mixed with those other elements we mentioned according to many different recipes, you might call them, depending on what conditions the finished product will have to face. It's vitally important that specifications be followed to the letter. Hence the endless taking of samples. Each one is identified as to the heat it came from. In the laboratory, shavings from the bar are weighed, the first of many determinations that will reveal the precise chemical and physical properties of the steel. Perfection, of course, is a difficult, if not impossible, thing to achieve. But the work of men like these helps America's foundries make a closer approach to it than has ever been made before. The incessant checking and measuring are followed closely by the company's founder and president, William J. Grady, who here watches as a bar is tested with electronic heat. Among the physical characteristics of the steel that are determined on this device is its tensile strength. How much pull it will take before parting, how much it elongates, the reduction of area, all are carefully noted. So as the metal from which samples were taken proceeds through the casting process and emerges as a giant machine part ready for cleaning and finishing, the men who produced it can be more certain about its internal structure than they can of the internal structure of their own hands. The casting emerges from the sand of the mold on a vibrator. Not a pound of iron ore went into the production of these quality steel castings, made from scrap, which many regard as useless, but actually is very precious indeed.
If someone came up to you and offered you 52 cents for a dollar bill, you'd probably look around for the nearest policeman. But actually, the dollar bill you're carrying today is worth only 52 cents compared to the one you carried in 1939. In the last dozen years, inflation has robbed that dollar of 48 cents. Yes, it's going to take 156 million policemen, every citizen of this country, to halt inflation from robbing us any longer. We can do it by increasing production, by insisting that our government practice economy, and put the federal budget on a pay-as-we-go basis.
The Rope Walk, Boston Naval Shipyard, a building in which our Navy supplements the thousands of supply items it receives from private industry with a little manufacturing of its own. Manila fiber, or abaca, from the Philippines is cut to lengths not exceeding 6 feet, then fed into the first of a series of machines that lubricate the fibers and comb them again and again into a uniform ribbon called sliver. After emerging from one machine and before going into the next, the sliver must be carefully paddled down so that the fibers, now parallel with each other, will remain that way. After 6 successive combings, several slivers are blended into one. In the yarn spinning room, slivers are fed endlessly into machines that twist them at a speed of 1,500 revolutions a minute into a coarse thread called rope yarn. The yarn is wound on bobbins, each of which holds about 4/5 of a mile. 100 bobbins are placed on a frame from which their yarns can be fed into the next operation, the twisting into strands. The sliver was twisted in one direction to make the yarn. Now the yarn is twisted in the opposite direction to make the strands, and the strands will be twisted the other way again to make the rope. This counterbalances any tendency on the part of the rope to unwind. Here we see the strands, 3 of them, being twisted into rope. Actually, the Navy word for rope of this size is not rope, but line, and you might get by calling it a hawser. And yet the place where it's made is called a rope walk. As the strands are twisted, they pass over whirling capstans onto the reel, a completed 7-inch line. This rope walk was founded in the days of sail, but today's blue jackets depend on ropes of all kinds almost as much as their predecessors for mooring, cargo handling, towing, for ladders, nets, and 100 other uses. Those veteran rope makers at the rope walk in Boston are determined that whether it's on a buoy tender or an aircraft carrier, the rope will be the best to be had.
Industry on Parade calls on Avon Products Incorporated at Suffern, New York, for a look at how a leading manufacturer of cosmetics and toiletries turns out some of its powders, creams, and lotions. Into this Abbey mixer go the lanolin, stearic acid, mineral oil, and other ingredients for fluff cleansing cream. Ingredients, like the perfume being added here, have all been accurately measured out in advance. Formulas for each product are, of course, closely guarded trade secrets. This is talc, basic ingredient for face powder. It must be thoroughly sifted and mixed with the extenders that give the powder its own special shade. Most spectacular phase of operations here at Avon is in the packaging of its products. Fluff cream goes into jars automatically, for example, like other cosmetics and toiletries, untouched by hands. In the cooling room, the cream sets. Then the jars move along to be capped. Girls put the caps in place, and machines finish the job. Now for the labels. Here's how those go on. Jars, 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 tubes, bottles, and boxes. The plant turns out many millions of units a year. Only with methods like these could such production possibly be achieved. This is men's aftershave lotion, bottled, capped, and labeled in an endless stream. In addition to the products we've seen, the company also makes toothpaste, shaving cream, deodorants, colognes, lipstick, and perfume. And even more comprehensive is the distribution of those products. For it's the firm's boast that its cosmetics reach every last city, town, and village in the United States. Here comes a parade of powder boxes. Girls spot check them to make sure the machines are filling them with the proper amount. Women play an important role in this organization, outside the plant as well as inside. For most of its 60,000 sales representatives are also women. Another amazing machine, the one that inserts the round boxes in their individual containers. The delicately scented substances are sold only in the home by representatives, many of whom use this as a pleasant, interesting way of augmenting their family income. Because of modern manufacturing and distribution methods, no longer does Milady need a fortune to feel like $1 million.
In America, more than 300,000 manufacturing companies employing close to 16 million men and women produce around $265 billion worth of goods. These companies range from the one-man shop to corporations employing thousands. Each grew as America grew, and you are responsible for their growth because you want and buy their products. As your demand increases, men and women in all walks of life risk their money for the purchase of new and improved machinery. The result? More and better products and at lower prices. That's the unparalleled system that brings Americans the good things of life.
Out of the cathedrals and churches of the land comes the music of the king of instruments, the pipe organ. And it was out of a plant in St. Louis that many of the finest of those organs came. The Kilgan Organ Company, with a history dating back more than a century in this country and in Europe, more than 7 generations, to the very invention of the pipe organ itself. Here, music and craftsmanship, artist and artisan, find a meeting ground. In the various departments of this, one of the best equipped organ plants in the world, the various parts, casework, mechanical, electrical, and pneumatic assemblies, are put together by people who seek not just technical excellence, but that intangible thing called art. A pipe organ's interior is a myriad of wires, magnets, and valves that control passage of air from the wind chests to the pipes and out through expression louvers that permit the utmost in tonal shading. The pipes themselves are fashioned from molten metals in very special combinations that are mixed and cast in sheets like this. The sheets later to be cut and formed into their proper shapes. Thickness of the wall of each pipe, like the length of the pipe, has definite bearing on the tone that pipe will produce. The length of a pipe might be anywhere from 1 inch to more than 30 feet, as we see right here. The console or key desk is an ingenious arrangement that must allow the organist to have full control of all the facets of this complex instrument without being an acrobat. When the final minute adjustments have been made and the organ pre-assembled, then taken apart and shipped to auditorium, school, or church, like the St. Louis Cathedral, the results may be enjoyed for many decades to come by worshipers whose praises for the Almighty will be expressed in the majestic tones of the pipe organ.